Hello everyone, I am Dr. Siddheshwar Chopra and today we'll learn very important concept in wave mechanics that is called Schrodinger wave equation and its two forms and their derivations. So let us get started. Schrodinger wave equation is a wave equation in terms of the variable psi and represents the fundamental equation in quantum mechanics. It has two forms. One is called the Schrodinger's time independent equation. In several situations, potential energy is a function of position alone and does not depend upon time. It is also known as the steady state equation. There is another form which is called Schrodinger's time dependent equation, which comes into picture because in most of the situations, potential energy is indeed a function of position as well as time. So let us start the first derivation, that is your time independent Schrodinger wave equation. Consider a system of stationary waves associated with a particle moving with velocity v and psi with a wave function, a function of x, y, z and t. Now the differential equation of that 3D wave motion is given as dou square psi by dou t square equal to v square grad square psi. That is the 3D motion. So we are using the Laplace operator or the Laplacian operator. This is equation number 1. The solution of this equation is of the form psi is equal to psi naught sine of omega t, where omega is the angular frequency in terms of 2 pi nu. Let us differentiate this equation, which is equation number 2, with respect to time. So I get dou psi by dou t equal to sine naught 2 pi nu cos of 2 pi nu t. Now I double differentiate it with respect to time. I get minus sine naught 2 pi nu whole square sine of 2 pi nu t, which can be written as minus 4 pi square nu square psi, which is equal to minus 4 pi square v square by lambda square psi. I have just used velocity is equal to nu into lambda formula. This is equation number 3. Equating equations 1 and 3, we get v square grad square psi is equal to minus 4 pi square v square by lambda square psi, which implies by rearranging we can get grad square psi plus 4 pi square v square by lambda square psi is equal to 0, which again implies we are using the de Broglie hypothesis now, and we substitute for lambda equal to h by mv. We get grad square psi plus 4 pi square m square v square by h square psi equal to 0. Now we know that total energy is a contribution from kinetic energy and potential energy. So E is equal to half mv square plus v. So I can write half mv square equal to E minus v, or I can also write m square v square is equal to 2m times E minus v. Why did I do that? Because I want to substitute for m square v square into equation number 4. After doing that substitution for m square v square, I get this equation to be grad square psi plus 4 pi square by h square 2m E minus v psi equal to 0, which implies grad square psi plus 8 pi square m by h square E minus v psi equal to 0. Now I use the reduced Planck's constant. So writing the same equation in terms of the reduced Planck's constant h cross, which is equal to h by 2 pi, I get this equation to be grad square psi plus 2m by h cross square E minus v psi equal to 0. I rearrange it and I get minus h cross square by 2m grad square plus v times psi is equal to E psi, or I can write it as the operator h, which is the Hamiltonian operator operating on psi. Operator operates on the right hand side. So operator h operates on the right hand side psi. It gives me E psi. E is your energy eigenvalue here. So for a free particle, the potential energy V is equal to 0. So the above Schrodinger equation reduces to minus h cross by minus h cross square by 2m grad square psi is equal to E psi. And this equation is the equation for your free particle. So this is a free state. Bound state is when V is not equal to 0. The next form is time dependent Schrodinger equation, which can be obtained by eliminating E from time independent Schrodinger equation. The differential equation of 3D wave motion is given as we saw in the previous derivation. It is dou square psi by dou t square is equal to v square grad square psi, equation number 1. We can now write the general solution to be, because this is a time dependent form, So the wave function must be dependent on time primarily. So that is psi is equal to psi naught times e to the power minus I omega t. So we differentiate this uh, general solution with respect to time. We get d psi by dt is equal to psi naught times minus I omega e to the power minus I omega t, which is equal to psi naught uh, times minus I 2 pi nu e to the power minus I omega t is equal to minus 2 pi nu psi. We have substituted for psi from the previous equation. Then I get minus I 2 pi E by h. I have substituted for nu in terms of energy and Planck's constant. And I get minus I E by h cross psi by replacing h with the reduced Planck's constant. So now I get E psi is equal to IH cross d psi by dt. This is equation number 2. So this is the equation we are getting. We know that time independent Schrodinger equation TISC is minus h cross square by 2m grad square plus v psi equal to E psi. Now here we substitute for E psi simply from the equation number 2. We get on the right hand side IH cross d psi by dt. Everything remains same. Only the right hand side we are having now written in terms of energy operator. So you have minus h cross square by 2m grad square psi plus v psi is equal to IH cross d psi by dt. The above equation, this equation is known as time dependent Schrodinger equation. You see here carefully, we have replaced the energy eigenvalue with the operator. That is the main difference between time independent and time dependent Schrodinger equation here. You can see this equation can also be written in terms of operator. You see carefully now, we have h psi. This is your Hamiltonian operator equal to E psi. E is again an operator because it is dependent on time now. So E is your total, E is your energy operator and H is your Hamiltonian operator. So that's all about the Schrodinger wave equation and its two forms. Thank you everyone.